Hello everyone, welcome to the series of O-Level Mathematics Class 9-1 IGCSE Cambridge syllabus. As you know, in the previous lectures, we are doing functions, and in the previous lectures, we studied inverse functions and we are following Collinsbook. So basically, we are doing exercise 21.2. Now, in our last lecture, we studied exercise 21b and we solved question 1, 2, and 3 of this exercise. We are going to solve question 4 last lecture. This question, you can see that we have a function g of x which is equals to 2x plus 5 divided by 3. And we have to find in the part A the value of g inverse of 3. So to solve this part, obviously we have to find first the inverse of g. So for the inverse of g, we do a usual step. So step 1, I am not writing the English sentence now, I am just doing the mathematical steps. So step 1 is instead of g of x, replace y. What we got? 2x plus 5 over 3. This is first step. In the second step, we have to find the value of x. So this value of x we can find, this 3 is dividing. It goes there and multiply with y, 3y equals 2x plus 5. Then this plus 5 goes there, it becomes 3y minus 5 equals to 2x. And in the end, this 2 is multiplying here, and in the left hand side, it is dividing with 3y minus 5 equals to x. So second step is complete. In the third step, what we have to do? We have to just replace this x with f of x. So 3y minus 5 over 2. So now you know we have x, right? And we have to find the inverse of g of x. So instead of x, we write g inverse of x, and instead of y, we have to place x minus 5 over 2. So we already did these steps in a very concise way in our previous lecture. Okay, so this is the inverse. So now we can do part A easily. So G inverse 3 is nothing but we have to put 3 in place of x. So 9 minus 5 is 4. 4 over 2 is 2. So G inverse 3 is 2. Likewise, we can do part B and C. So for part B, we have to find G inverse of 2. So for G inverse of 2, we already know what is G inverse of 2 is. So G inverse is 3x minus 5. So 3 into 2 minus 5 over 2. So it becomes 3 to 6 minus 5 is 1 divided by 2. And part C is also easy. G inverse of 0. So we have 3 into 0 minus 5 over 2. So it becomes minus 5 over 2. And this question is complete, both part. Okay, so now let's do question 5. So in question 5, they are giving us the function. The function is f of x equals 10 minus x. And in part A, we have to find the expression of f inverse of x. So for this, we found out just replace f of x with y, 10 minus x, right? Then this x come here and this y goes there, so it becomes 10 minus y, right? So because we have to find the value of x in a positive sign, right? So this minus x come here, it become positive x. Now the next, so this is first step, the second one, the third one is we call it f inverse of x, this x, and this is 10 minus y. And the fourth one is f inverse x is equal to 10 minus x. So usually we can do step 3 and 4 in one step, but sometimes a student make mistakes. So instead of y, they write f inverse of x. Instead of x, they write y. So that's why uh, to eliminate the confusion, do these two steps in a separate steps. Okay, now we have f inverse x, and this f inverse x is nothing but what? 10 minus x. So you can see that we have now this value f inverse x equals 10 minus x, and again f of x is 10 minus x. So you can see that both the functions now for the what do you notice about f of x and f inverse of x? So in part B we can say we noticed that the function f of x equals 10 minus x has its own inverse, right? Or instead of s is its own inverse. So function f is the function whose inverse is also the same function, right? So here f of x, so you can write this line as well, that f of x equals f inverse x. So this is the function which has this quality. So sometime in exam, this type of question appears that we are given a function and we have to find the inverse, and eventually it comes out that this function is the inverse of itself. Okay, so this question is also complete. Okay, now let's do question 6. So in question 6, we have to find inverse of x for each of these function in these three parts. So one thing to notice that up till now we are doing exercise 21b, and up till now all the functions we deal are all the functions till question 5 are polynomials, right? So you can see that there is no function in which x appears below, right? Or the power of x is negative, or you can say in a fraction. So like in this question, question number 5, 10 minus x. So you know the power of x is 1. So polynomial are those functions in which the power of variable is positive, right? So whatever variable our function has, x, y, z, whatever variable up till now we have in a function, all the variable has positive power. Power of variable is positive integer or 0, right? So power can be 0 or can be positive integer. So these are these functions called the polynomials. Now in this question, you can see that in like in part A, we have 8 over x. So now x is in the denominator, and when this x go upwards, like so you can write it as x. Now plus 1 becomes minus 1. So you can see now the power is negative. So it means this is not polynomial, or in short, whenever variable come in the denominator, in a fraction, in a denominator, so these functions are not polynomials. So what they are called? These functions are called rational functions. So up till now, till question 5, we have polynomials. So in this question, question 6, we have rational functions, and where we have to find the inverse of these functions. So let's do part A. So part A is f of x equals 8 over x. So the steps are again similar. First, y f of x become y 8 over x. Now x equals 8 over y. Again, in third step, x replace x with f inverse x 8 over y, and then y become x. So f inverse is 8 over x. So you can see that this is again the function which is its own inverse. We have f of x is 8x, 8 upon x, and f inverse x is also 8 upon x. Let's do part B. So part B is now 20 over x. So f of x equals 20 over x minus 1. So again y equals 20 over x minus 1. Now y, so this is first step. Second step is y plus 1 is equal to 20 over x. Then this x goes here, and this y plus 1 comes in the denominator. Now replace x with f inverse x, 20 y plus 1, and then y with the x. So f inverse x become 20 over x plus 1. So this is f inverse x. So part C is really simple. Part C, do yourself. Okay, and this question is again complete. So the only thing to learn in this, that now we are doing the finding the inverse of the functions which are not polynomial but are rationals, and finding the inverse of a rational is same as finding the inverse of polynomials. Okay, now let's do question 7 of exercise 21b. So now we have function f of x equals 2x plus 2x minus 4. In part A, we have to find inverse. So inverse is really easy. Y equals 2x minus 4. So we replace f of x with y. Then we found the value of x. So y, this is minus 4 become plus 4, and this 2 is multiplying. It comes in the divide. So x equals y plus 4 divided by 2. And in the third step, y plus 4 over 2 equals x. We replace x with f of inverse x, and then y with x. So x plus 4 over 2 is equals f inverse x. Right. So this is part A. Now part B is something that we have to look, which is on the same axis draw graph of y equals f of x. So we have to draw graph. Okay. Now, and for the graph, what graph we have to do? Y equals f of x, 1, and y equals f inverse of x, second one, both in a same graph, right? In the same axis. Okay, so let's first prepare these. So y equals f of x. So y equals f of x is 2x minus 4, 2x minus 4. So this is our equation 1. Second one is y equals f inverse x. So y equals f inverse x is, so x plus 4 upon 2. So we can write x like this, x upon 2 plus 4 upon 2 equal to f inverse x. So I am just simplifying it. So we can write it 1 upon 2x plus 2 equals f inverse, right? So this is y equal f inverse x, and f inverse x is 1 upon 2 x plus 2. So this is equation 2. Now we have to find the graph. So for the graph, let's make first axis. So this is x, this is minus x, this is minus y, sorry, this is plus y, this is minus. So we know to make the graph. first we have to find the 2 points for each, right? So this is why what so in our lecture of the graphs of a straight line, we see how to make a graph. So just recalling this method here. So we know that if I want to draw this, so what I need 2 points. So I need 2 points if I want to draw this. Same if I want to draw this, what I need again 2 points for this as well. Okay, so let's take one by one each equation. So y equals 2x minus 4. This is our equation 1. And find the 2 point of this equation. And how can we find 2 point? We know the method of intercepts. So for y-intercept and by using x-intercept, we can find 2 point, and finding point with intercept is really easy. So let's y-intercept. So y-intercept means x equals 0. We have to put x equals 0 in the equation just. So y equals 2 into 0 minus 4. It means y equals minus 4. So we put x0 and got y minus 4. So we got our first point. Second, x-intercept. So x-intercept means y equals 0. So y equals 0 means y equals 2x minus 4. So y0 equals 2x minus 4, and this is 4 equals 2x, and then x equals to 4 upon 2, and x equals to, very easy. So x is 2. So now the next point is x2. So we put y0. So y always come in the second position. X is 2. So this is 2. 2 comma 0. So we found 2 points for this line. So it means our work is done. Now let's found 2 points for equation 2 as well. So equation 2 is, i.e., the inverse equation is half x plus 2, y equals half x plus 2. Again, for y-intercept, x is 0. So when you put x0 in the equation 2, what we get? Y equals 2. So the point we got x0, y2. Okay, let's do x-intercept. It means y is 0. So when y is 0, half x plus 2, this 2 goes here, it becomes minus 2, half x, and this 2 is dividing, goes there, multiply with 2, 2 to the 4, y to become minus 4, so x minus 4, then what, y0, x minus 4. So these 2 points are for equation 2. Now with helping with these points, so one thing notice that here first point is 0 minus 4, and here point is minus 4 comma 0. So just points are switched because they both are inverses of each other. So here second point is 2 comma 0, and here second point is 0 comma 2. So again the point is switched because they are the inverse of each other. So its point is 0 minus 4. So the inverse's point is minus 4 comma 0. If this point is 2 comma 0, the second function point is 0 comma 2, right? Okay, so now let's make first the equation 1, this one equation. So to make this equation, we have to draw these 2 points. The first point is 0 comma minus 4. So let's first draw number on axis. So this is 0 comma 0 point, x is 0, y is 0. Okay, then 1, 2, 3, 4. Okay, here minus 1, minus 2, minus 3, minus 4. So till where we have to make a scale? So see, when you find out the point, what is the largest number? So the largest number is -4. So in each axis, you have to draw the scale of till 4. 1, 2, 3, 4. So -1, -2, -3, -4. Here +1, +2, +3, +4. Okay, now I'm making first equation, which is equation 1. So equation 1 point first is 0, comma -4. X0, x is 0 here, y is -4, my -4 is here. So this point is this. The next point is 2, comma 0, x2, y0. X is 2 here, y is 0 is here. So just join these 2 points. So make it with the scale so the line become very good. So I am just making it roughly. So this is the equation 1 line. So equation 2 line now, 0, comma 2 and means y0, x2, right? x0, y2. So x0 is here, y2 is here. In the same way, -4 is x. So -4x is here, right? So you can see easily that 0, comma 2 point is this. This is the point 2, comma 0. Sorry, this one 0, comma 2. So x0, y2, and then -4, comma 0. So this become another equation. This is equation 2, and our question is done. I hope you understand. Now they are saying that where do the line cross in part C. So for this, what we have to do, we have to move it further and move it further and see where they touches. So at what point it touches, just go downward, so approximately 5, and go upwards, right? And find out like something 4.5 or 5 as well. So this is x value, this is y value, and write on C. So when you make the graph with on the graph paper with the scaling, so you got the right point of x and right point of y. So this x and y is your part C answer. Right? So approximately we have like 4.5 something, right? And so the question is complete. Okay, let's do question 8 of 21b. So in this question, we have to ask that f of x equals what? X plus 5, and we have to solve the equation such that f of x equals f inverse of x. So for this, what we have to do first, that make, so we are given f of x, which is x plus 5 upon 2, right? And we have to solve this equation f of x equals f inverse x. So first we have to find f inverse of x. So for this, what we have to do, put y, x plus 5 upon 2, then 2y minus 5 equals x, then f inverse x equals 2x minus 5. So I did both step in one. So this is f inverse x. Now the question is, solve the equation f of x equals f inverse of x. So we have to take f of x equals f inverse of x. So f of x is x plus 5 over 2. F inverse of x is 2x minus 5. This 2 is dividing, it goes here. So x plus 5 is equal to 2 into 2x minus 5. Then x plus 5 is to 4x minus 10. Right now what we have to do, then this is plus 5, this minus 10 comes here, plus 10, this is 4x, this goes here, become minus x. So 15 equals 4x minus x is 3x. Now 15 over 3 equals x. 3 1 2 3 3 5 into 15, mean x equals 5. So we solve this equation, i.e. found the value of x, and this question is complete too. Okay, now let's do question 9. So question 9 is, now instead of f we are given f inverse of x, which is 3x minus 2, and what we have to find, f of x. So the procedure is same whether you are given f of x and asked to find f inverse of x in a question, or whether you are given f inverse of x and asked to find f of x. So method is remains same, which is the 4 usual step which we are doing when we are finding inverse of any function. So again, this now instead we have f inverse, so we put f inverse as y. So y equals 3x minus 2, first step. Second step, we have to find the value of x. So y plus 2 equals 3x, y plus 2 divided by 3 equals x. So this is step 2. Now in step 3, when we are finding inverse, i.e. when we are given f of x and finding f inverse of x, what we do, we write replace x with f inverse of x. Now we are given f inverse of x. So instead of x, we replace it in the part step 3. We replace it f of x because we are now finding f of x, not f inverse. F inverse is given. So previously, when f of x given, we replace x with f inverse x because we are finding f inverse x. Now we are not finding f inverse x is given. So we are finding f of x, so we replace x with f of x. Now in the fourth step, replace y with x plus 2 over 3 equals f of x, and this is the step 4, and we are done with the exercise. So this is the exercise 21. Exercise number 21b is complete now.